Rebreathers are often seen as a dark and scary side of scuba diving, but they're starting to creep their way into the recreational side, and you can even do your PADI open water on a rebreather if you like. So normal scuba, where you blow bubbles, is called open circuit, or OC for short, because every time you breathe out, you lose a lung full of gas. Rebreathers recirculate that gas and turn it back into fresh air, so they are much more efficient at gas management. Your exhaled gas gets passed through a scrubber to remove the carbon dioxide, and sensors then analyze it and O2 content just to top it back up. By this method, you can breathe the same lungful of gas over and over again until either the scrubber is saturated or you run out of pure oxygen to top it up.
The goal of the TDI Rebreather Discovery Experience is not to teach you everything there is to know about rebreathers, but rather to give you an overview of the rebreather and get you in the water so you can experience CCR diving firsthand. It starts with your TDI instructor going over the basic components and operations of a rebreather. The breathing loop circulates the user's exhaled gas through a scrubber canister containing CO2 absorbent. The diver breathes through a special mouthpiece that ensures gas only flows in the correct direction. Flexible counterlungs help ensure that the diver is always able to breathe gas at precisely ambient pressure. Multiple oxygen sensors in the unit's electronics inform the diver of current PO2 levels in the loop through a wrist unit and heads-up display, or HUD. Electronically controlled rebreathers, or ECCRs, automatically inject oxygen into the loop as it is metabolized by the diver to maintain a constant partial pressure of oxygen. Many rebreathers also allow the diver to control this manually. By maintaining a constant PO2 level, rebreathers ensure that divers are exposed to the least amount of inert gas possible. This can dramatically reduce the need for decompression. After going over the fundamentals of rebreather operation, it's time for rebreather discovery participants to don the units and enter the water. Their TDI CCR instructor will be with them every step of the way. In shallow water, the instructor will have each diver practice opening and closing the mouthpiece and breathing from the loop. Divers also practice bailing out to open circuit before the diving experience begins. Now it's time to actually get below the surface and practice breathing underwater in an entirely new way. Among the first things participants discover is that, unlike open circuit, breathing has little to no effect on the diver's overall buoyancy. Buoyancy control on rebreathers is done entirely through the use of the BC air cell. Then there's the silence. Rebreathers generate virtually no bubbles at depth and very few on ascent. This makes rebreathers ideal for approaching sensitive aquatic life that would normally be spooked by the noise of your exhaled gas and bubbles. After just a few minutes, the experience of diving on closed-circuit scuba will seem as easy and natural as diving on open circuit.
How a rebreather works. A closed-circuit rebreather, CCR, is a closed-loop breathing source. This means that the gas you inhale goes back into the rebreather, the loop, and not out into the water like conventional scuba. However, for this to happen, there are some very important parts that the rebreather must have and that the diver must verify is in working condition before every dive. First, when the diver places the loop into their mouth, they will begin breathing from and back into the mouthpiece. A critical component of the rebreather mouthpiece is mushroom valves that ensure a one-way direction of flow. This is so that the exhaled breath of the diver can travel in a one-way direction, ensuring that the exhaled gas will circulate in the proper direction so the rebreather can function properly. Also, a rebreather must have a counterlung. Most units are fitted with two, however, there are some exceptions. The counterlung gives breathing volume to the unit so that the diver can breathe freely, not feeling starved for air. There are many different variations of counterlungs that manufacturers make. However, the purpose of this explanation is just to show why they are needed, and not the variations. The rebreather has a CO2 absorbent canister. The purpose of this is to remove CO2 from the exhaled gas of the diver. Without this, the diver would certainly succumb to CO2 poisoning. Types of scrubbers vary by manufacturer, but they all serve the same purpose, to remove CO2. This is why it is important that your mushroom valves are properly functioning so that the gas can travel in one direction, ensuring that spent air comes in contact with the scrubber. As the diver breathes from the loop, they will metabolize oxygen from the loop. Ultimately, this will deplete the oxygen in the loop until the gas becomes hypoxic and cannot sustain life. The way this issue is resolved is by adding oxygen to the loop by some means and oxygen sensors with a monitoring device, so the diver can verify the content of the loop. The way it is accomplished varies by manufacturers. Some units are mechanical, MCCR, having a constant flow of oxygen at all times into the loop. There are various mechanical devices that are used depending on manufacturer and design. Another way that oxygen can be added is electronically, ECCR. A computer system is added to the rebreather, and when the ppO2 of the gas falls below the set point that the diver has set their unit to maintain, it sends a signal to a solenoid to fire oxygen into the loop. Some rebreathers are a mix between these two and are called hybrid CCRs, HCCR. However, most all units will have some sort of manual addition valve that the diver can manually inject oxygen into the loop in case one of the devices mentioned above fails. This is how an oxygen rebreather works. However, if the diver desires to go deeper, they must be able to add a diluent gas into the loop. The purpose of this diluent gas, which is generally made up of air, is to dilute the oxygen content of the loop and provide a low oxygen gas to make up the breathing volume so that the diver does not starve for air. As we know from previous courses, the ppO2 of our gas should not exceed certain levels. Generally, on a rebreather, the diver will run a lower ppO2 than open-circuit divers. This is because rebreather divers are generally exposed to higher ppO2s for longer amounts of time. The way diluent enters the loop varies by manufacturer. Some use a device called an ADV, automatic diluent valve. This is usually positioned somewhere inside the counterlung and will fire diluent into the loop when the counterlung is near fully collapsed. Another way some manufacturers get diluent into the loop is a MAV, manual addition valve. The diver will manually add diluent as needed on the dive. In conclusion, there are many types of rebreathers and many different ways they accomplish the same goal, which is to enhance gas efficiency, allow for longer, quieter dives, and give the diver many more options in failure scenarios. Rebreathers require rigorous training and maintenance, but offer unmatched benefits for technical and recreational divers alike. None are without their flaws, but once you understand your unit and become a competent rebreather diver, you will never look back to open circuit again.